So this circuit breaker here is going to connect to the battery, and I'm going to use the A&L fuse block as a terminal post for that. So I can wire that up, and I can wire the Renogy MPPT charge controller to the two circuit breakers, and I can also connect my inverter to the A&L fuse block. So essentially what I'm trying to do here is I'm just trying to get the lengths, measure out the lengths so that I can cut my cables and terminate the lugs onto the cable. In this case, I'm starting with this 6-gauge wire. I'll run a 2-gauge wire from this point here out to the battery. 200 amp fuse will be, or maybe a 225 amp fuse, and then the inverter is going to be mounted over that direction there. So I'm going to pull it kind of tight and then cut directly over the terminal. I want to crimp the lug in a way that it lays flat, so I'm going to mark how the cable lies. So I'm not putting any pressure as I strip this insulation. I need a 1/2-inch lug here for these breakers, and I don't have one, so I'm just going to go 5/16, and that should do it. Okay, so I got this lined up. Let's check that. That looks good. So that should lay flat. I have my line on the blue tape. Yeah. So let's see. There we go. So that looks good. So I can heat shrink that, and that should work out just fine. Got some 1/2-inch here. Let's see, I think I can cut this into thirds. So the 1/2-inch will be for my 6-gauge. I'll use this 3/4 inch for the 2-gauge. And while I still have this side panel up, I want to make sure I get this ground cable run. And I've been debating whether to run it straight to the battery or some other direction. And I think what I'm going to do is I'm just going to use my common ground bus back here. And so it'll have to run out the top of the DC to DC charger, and then it just can go underneath the inverter. So this MPPT charge controller and the DC to DC controllers has a positive out, and that's this post right here. And so I need to connect this post to this circuit breaker here so that it can in turn charge the battery. Yeah, I got a little bit of twist and it lies in there nice. So I'll be able to, okay, I like that. The alternator feeds to this post right here, and before I connect the alternator to this post, I need to fuse it, so that's what I have this circuit breaker here for. But what I have feeding in here is 4-gauge cable, and I don't have any scraps of 4-gauge. All of my excess is currently connected to the alternator and inside the truck. So I'm going to get that last bit and also the bits above the batteries, connecting to the batteries, get those last bits when I'm inside the vehicle. So all the finishing touches are going to happen inside the vehicle, and I just need to prep out this apparatus and get it ready for mounting in the vehicle. So I got to take my inverter off so I can access my flange here. That'll be bolted down to the floorboard, and yeah, I'm liking it. I'm thinking we're pretty close. So the end of the tunnel is getting brighter. Okay, so I got the battery box mounted in the truck. That's a good thing. And so at any rate, the next step is to start putting in the batteries, power inverter, charge controller, get all the last finishing touches for the wiring taken care of. So I countersink my fasteners into the acetal shelf here, this 1/2-inch acetal board, and I did it in 3 places: at the rearmost, in the center, and then also at the very front end. Didn't use a lot of fasteners, mostly used the wood screws, and then I used the hex head screws in the back. And in the back I had to use some pretty long screws. I think I went with 1.5-inch self-tapping screws with the hex head in the back. Just had to go through that insulation there. So I have plenty of wiring sticking out here waiting to be used. I also have some future expansion planned out as far as bringing extra wiring from the outside of the vehicle to the inside. So that's going to be via this wire loom right here. So there's nothing in it right now, but that'll be for future expansion. In addition, I have my main ground cable here, and this will go towards the back and then inboard where the main ground bus bar is. I also have my main power coming in from my alternator that will connect to the DC to DC charger, and I also have a ground wire that will connect to the inverter's chassis ground. And then, yeah, lastly, I also have a post-ignition positive power cable, and so that will be a trigger to the DC to DC controller to let the controller know that the truck has been started. Since I do have a smart alternator, this will be a necessity to connect this wire to the DC to DC charger. And then so the other preparation that I have is for the batteries. The batteries need to be strapped down to the shelf, and so the purpose of these straps is to provide security for vertical motion, not so much lateral. I have some slots where the shelf is penetrated where the straps can feed through, so that's what these old straps are here, and I'll just use these to fish the new straps through the shelf. In anticipation of vibrations and some possible wearing on the batteries themselves, I have a little mat. Basically, it's something you can pick up at Home Depot or Lowe's or whatever, and it just goes on the bottom of your toolbox trays. It's for the toolbox drawers, and so I have that to take up some of the gap that I afforded the box, a small gap forward and aft, but not on the sides. So in order to fish this underneath the shelf, I have limited access underneath there. I checked with MacGyver, and he said it'd be okay just to use a regular office stapler to staple this strap to the fish line, as long as I use some painter's tape to cover up the staples. All right, I'm a dork. Now I remember why I came up with the idea to fish tape it through, is because I need to string this thing. I need to string this through the battery, through the back side of the battery. So I got to kind of start over. I got the buckle, the strap, everything oriented the correct way. I have the strap fed through the little, I don't know, the little hole on the battery. Okay, let's see if this works. So I think I lucked out as far as where the ratchets were landing. Obviously it's not an infinite adjustment using the ratchet, so I didn't want to over torque it, but looks to be pretty snug. And so what I'm using is as a foundation for the ratchet, up against the battery I have this product here, which is basically shelf liner for your kitchen drawers and cabinets. Got some 1/4 inch high density polyethylene HDPE, and then closest and up against the ratchet is my toolbox liner. All right, I'm okay with this finally. All right, well, it's getting pretty late. Hopefully there's enough light here where you can actually see what's going on, but I got everything wired up and I'm getting ready to turn the ignition on. And I just remembered I got to get my paper clip so I can set the battery type. So I'll go grab that before I start it, but everything's hooked up here. I have the circuit breaker to the alternator and to the battery open currently, so I don't see any lights, but let's get the alternator going. I got the blue light set. Oh, and there goes my alternator. I don't hear any explosions. I don't smell any smoke. I did use the paper clip to change the default battery type setting to lithium. Post ignition positive setup, and I think everything's working. All right, well, I just wanted to actually show you guys when I first tried it to see, you know, I'm not going to bother testing the batteries. I know they have a charge, but all right, anyway, this is good stuff. I'm so happy, really happy. Well, it's the next morning, and now that I have a little more light, I just want to kind of go over what I have installed here. And then I think we should test the power inverter too, maybe put a lamp in it or something. So at any rate, the truck is turned off, the ignition's off, the key is out, and this is what the lights look like. A blue light here, this indicates the type of battery, and so you can change that out for AGM, flooded, whatever. I have a green light now, and it's yellow when the batteries need a charge. And so if I disconnect the DC to DC charger here on this circuit breaker, where it's connected to the batteries there. If I disconnect this, it automatically seems to turn yellow for a little while the charge controller, while the DC to DC charger thinks about it for a little bit. So I'm not sure what's going on there logically, but I thought that was pretty interesting that when I disconnect it, wait a while, and then reconnect it, it'll turn amber like it's doing a systems check or something. So this is for solar. Solar would input into this area here. There's a terminal there for the solar panels. Whoops, solar panels. So since I don't have any solar panels, there's nothing indicated here. And then this is for the alternator. So if there was a charge coming from the alternator, like the truck was turned on, then that would be red and solid red. And then there's a flashing would indicate some other issues. Same thing here, if this solar panel was connected here and it was working, it would just be a solid red. So there it is. I have the battery temperature sensor is just I just kind of dropped it in here and kind of out of the way, so it's kind of resting in there. And the other one that I have connected that I mentioned already, this is the post ignition hot terminal, and I have that connected there to the to that. So here's what we got. Coming from the alternator is my positive, goes to this circuit breaker. This one's rated at 70 amps. Renogy says use a 75. I have this cable here is a 4 gauge, and then I have a 4 gauge also here, and then that's terminated on the lug there. And so that circuit breaker is currently closed. And then out the top, this is the ground cable here, and I have the ground, and that's going back to where my bus bar is. And similarly, there is a ground here, and then so all of the grounds are terminating on the inboard side of the battery box. This green cable here, if I recall correctly, 8 gauge is what the inverter calls for, and I have that terminated here on the inverter's chassis ground. This is the inverter's ground here. This cable looks really big, but I had put some black heat shrink over it because all I had was red cable. And so at any rate, this is the 2 gauge that is recommended from the inverter. Similarly, I'm using 2 gauge here to connect the batteries. So I have, for example, a 2 gauge cable connected here. Currently I'm using a 200 amp A&L fuse. I may bump up to a 225 if this blows. And then this comes out and terminates right here on my inverter. So this fuse right here is dedicated to the inverter. And then I have 100 amp service, which is connecting on this battery side of the A&L fuse block. I'm gonna turn you guys upside down. That's the 100 amp service right there. And that is going to this 100 amp A&L fuse, and then that terminates over here on this fuse block. As far as wiring up the final components and stuff, I think that pretty much covers it. The only other thing that I'd like to mention is that I thought about it and I looked at a couple diagrams. Well, okay, first off, I anticipated that I was going to take the service that was coming from the DC to DC charger, or maybe the MPPT controller. So this is out positive coming from the controller, and then that goes to this circuit breaker here. And I used a 60 amp, they call for a 65. That's fine. I could probably even bump up to a 70. This 6 gauge cable here is good enough for that 70, especially on this short run. So at any rate, the point that I was trying to get to is this, that I initially thought I was going to terminate this cable on the A&L fuse block here, and it just was a little hokey. So I ended up going directly to the battery lug right there. So I have, and that's the final point that I wanted to get to here, in that I have these batteries are hooked up in parallel. So if I keep connecting these batteries in parallel, I will always have 12 volts. So the alternative to that would be to wire them in series, where each other battery would have a positive connected to the negative, and it would kind of daisy chain that way. But the point here is that I have these wired in parallel, so positive to positive, negative to negative. And this is where I was mentioning, I saw a couple different diagrams, and the one that made sense most to me, considering that we're dealing with DC current, is that I take the connections, whether it's an input like this cable here coming from the DC to DC charger, whether it's that input or it's some sort of draw like my 100 amp or whatever, it's coming off this post. And then instead of using the ground on the same battery, I'm connecting the ground on this battery. Since I only have two, there's only one other option. But if I had multiple batteries on one end of the battery array, I would put a ground connection going to my common ground bar, and then on the other end I would be connecting the positive battery terminal. So I hope that kind of makes sense. I've seen a lot of them where everything is to one side, negative and positive, and that just didn't really make that much sense to me, so I opted for this, and for what it's worth. All right, let's test the inverter. I'm a little scared. I do have a fire extinguisher nearby, actually within 10 feet, and hopefully everything works. I'm on the driver's side of the vehicle, and here's what it looks like from this side. So essentially this is the fuse block I was mentioning. This would be 100 amps worth of service, and then I got some bus bars here for the ground, and then this is my power inverter, and these are the plugs here for the 120 volt alternating current, and there's the switch to turn the inverter on. So everything is fused and ready to go. So I really shouldn't have to turn the truck on, but I don't want to push my luck necessarily. I am a little apprehensive, maybe. I don't know. I don't want to push the limits right now. So it's going to take a second before I see the red light on the DC to DC charger, but it is on right now. All right, let's give it a go. Well, there's a green light. I have to say that this has been a little more work than I anticipated. Maybe not more work than I anticipated as far as what the finished product looks like here. This is maybe not more work. I just more tedious, more time consuming. You know, more trips to the store. All that sort of stuff. So the project lasted many days longer than I had budgeted for, planned for. But you know, now I'm on the road to the other things that I wanted to accomplish. So this is one small goal, one small hurdle, and you know, there's just more to come. That's all I can say. I'm really excited about this. And so thanks for watching, and tune in for the other videos where, you know, I start really putting this thing to use. I hope it works really good. Like I said, the main goal really, I guess the one goal was to charge my bicycle, and I don't know if that inverter is going to do it, but I think it will. And so anyway, stay tuned guys, and thanks for watching.